Welcome again, everyone. In this video, I want to look or continue the idea of limiting reagents, but add the idea of something of reaction addition. So, meaning that we could, in principle, if two reactions, or if we can, in principle, sum reactions and look at them as a combined entity. We don't have to look at them as separate things, given that, because the stoichiometric coefficients will still dictate the overall reaction equation and will still dictate the limiting reagents and the excess reagents. So in this example, it says, what mass of water and carbon dioxide is going to form when 400 gram of propane and 116 gram of butane and 430 gram of oxygen react. Now we know what the combustion reactions are for propane and the combustion reactions are for butane. There's actually just a little writing mistake there. That should just be a 2 there. So we know these are separate, but what we can do is, if both butane and propane are being reacted and they're both reacting with oxygen, we can actually sum these and get a big overall equation where we say we have propane we have butane and if they both react, they will react with a total of 18 mole of oxygen. So meaning 1 mole of propane and 2 mole of butane will react with 18 mole of oxygen in total. You see how it doesn't really change the idea? You can still think of it as 1 mole of propane reacts with 5 mole of oxygen and 2 mole of butane reacts with 13 mole of oxygen, but it's in one equation now, so it makes it easier to figure out what is going to be the limiting reagent in our given information. Anyway. Right, and then that's going to form 11 carbon dioxide, mole carbon dioxide, and 14 mole water. Okay, so that's our overall equation. So as normal, we start by determining the limiting reagent. So how to do that? Well, we have to start by calculating the number of moles of propane, butane, and oxygen. Ooh, that's the wrong thing. Right, and that's going to be the masses over the molar masses. And you should get values of, so the number of propane is going to be 9.07 and so forth. Mole propane. Butane is going to be about 1.99 mole butane. And then the oxygen is about 13.43 mole oxygen. Okay. And now you can go through your process, you check which one is limiting, but I think by just eyeballing it, we know that from our chemical equation, if we just write it down, ratio-wise, that 1 mole of C3H8 will react with 2 mole C4H10 will react with 18 mole. Ideally, that's what the chemical equation tells us. 18 mole of O2. So we can see, okay, we need 1 mole, but there's 9, okay? 2 mole, there's roughly 2. I mean, 1.99 is about 2. And we need 18. So 1, 2, 18, and the oxygen is 13. So, I mean, clearly, these two are then, this one is in excess. This one will also be in excess. Therefore, O2 is our limiting reagent. It's our limiting reagent. And you can do this by formal calculation. I think something that would be useful to do, for example, is just calculate how much, so 13.43 mole of oxygen will react with how much butane, for example, and then you just show it's going to be less than 1.99 moles, and hence it must be limiting. You can do something like that. That would be the easiest. I use the eyeball method here because we have 3 reagents, so it's easier to quickly determine because you technically have to do 2 calculations, but then once you know which one is the smallest, you can use logic to determine, you can do 1 calculation and then argue it backwards. Right, so the amount of O2 is going to dictate how much water will form and how much CO2 will form. I'm just going to do the water calculation because it gets quite tedious. There's a lot of videos on how to do this kind of thing. So how to get the number of moles of water is, of course, we know from our chemical equation that 14 mole of water is formed for every 18 mole of oxygen that reacts. But how many moles of oxygen do we have? We only have 13.43. Hence, that will lead to only 10.45 mole water forming. And this means that the mass of water that forms is going to be equal to the number of moles of water multiplied by the molar mass of water. Molar mass of water is 18.015, and that's roughly rounded to 3 significant figures, 400, 116. Oh, it's not dots. There's not a dot in any of these cases. So the 400 is without a dot, so it means it's 1 significant figure. In other words, your answer here is going to be 200 gram. Okay. It's 200 gram water that is formed. You can quickly check carbon dioxide. It's going to be, what's that? 8 over 18, it's about half. Okay, I'm actually not sure. We can calculate, I mean, it's the same idea. Number of moles of carbon dioxide, mass of carbon dioxide. You can get there. All right. So that's the basic idea. The idea of this example is to really show you that you can sum equations if you're given a bunch of them, and you can still determine which one is the limiting reagent, and it will still dictate how much is the product that's going to form. Even if there's multiple things happening, as long as it is important in all of the equations, of course, because both propane and butane react with oxygen. Oxygen is important in both of them. If oxygen was irrelevant, then of course it could not have been limiting. Okay. So that's it for this example. Thank you for watching, and I'll see you in the next video.